Okay, so here's that video that we talked about in class of how to do one and two-way chi-squared with Excel. So what this is going to do is this is going to give you you can paste any data that you have in, and it will give you the chi-squared test statistic and also the p-value, the degrees of freedom that you'll need. And we'll see if we can also put in the critical value as well. Okay, so we're going to start with a one-way chi-square. The first thing that you want to do is just put in your labels. So we want to do expected and observed. These can be anything. We'll put some values in a minute, but we're just going to leave them blank for now. Okay, so the next thing you're going to need is the number of categories you have, and then your output is going to be the degrees of freedom, chi-square test statistic, and the associated p-value. Okay. The first thing we need to do is put in our formula here. So the formula, of course, for chi-squared, for one-way chi-squared that we're going to be using is chi-square equals the sum of we're going to need two of these. Every observed value minus every expected, well, a particular observed value minus a particular expected value squared divided by the expected value. And that's it. So each one of these, this is for the whole thing. We've got this sum. We're going to do that later. What we're going to do right away, just for each of these cells, is this right here. The observed minus the expected squared divided by the expected value. So we're going to put that right here. And the way that we're going to type this in, of course, we start with an equal sign. And then we're going to put in two parentheses. We want to do observed minus expected. So B2 minus B1. Close your parentheses just so that operation is done first. You're going to square that. You're going to close the second set of parentheses so this operation is done second, and then we want to divide it by the expected value, B1. And there you go. We're going to copy this all the way across. Let's go through 4 alphabets. So we'll go to CZ. The reason I'm going to CZ is that's just slightly over 100 groups of data, and there's just absolutely no way that you'll ever need 100 groups of data. It's totally ridiculous. Here's where you're going to put in how many categories you have, which this is what will hopefully never be more than 100. I don't know how. That just seems impossible. Let's go with 6 for now. Let's throw some data in here, just for the fun of it. We're going to expect 25 values for, or 25 in each of these categories. 1, 2, 3, 4, 5, 6. Yeah, okay. And let's say that this one we got 23, this one we got 22. This one was 30. I have to do this math in my head, and I'm failing. at the skill. Okay, so it's 150, and so far we've got 75. Oh, we're exactly half. Yeah, okay, I see that. I could have easily figured that out. Okay. What a dumb person. Okay, let's say this one's 33. Now we have to come up with 42. This one's 20. This one's 22. There we go. Okay. So that's our observed and expected values. We can clear that. So we've got values that we want to see right here. This is what we're expecting to see. And this is divide by 0 error because there's nothing there. But that's okay. We're not going to use these in the calculation. So one really quick note about this formula that we've got here. How does this work if we have 25 here, or if we have 250 and we have 230, we have 1.6. Well, if we had 25 and 23, we have 0.16. So you can see that it's working correctly. The size of the error that we've got here is essentially, correcting itself because of the formula we've got here. So it's an accurate formula. It's taking in what we're putting in. We can make them about twice as big, and this is twice as big. So that's good. The error value is just a little bit bigger. So that's great. This is exactly what we'd want to see. Okay. Let's take it back to what it was, 25 and 23. 6 categories. This is right. Degrees of freedom. This is a really easy calculation. All you're going to have to do is tell it to take your number of categories minus 1, and it's 5. Excellent. Here's where we're going to do the summation of these right here. And this is where it gets a little tricky. So if we were going to do a typical sum, we'd go sum B3 through G3, right? There you go, 5.44. This is the number we're looking for. This is what we should get out if we've done this correctly. Oops. I'm going to put that right here just so we know. So what we need to do is make this part of the formula change based on this right here, the number of categories. So this can't be static. It has to be something that updates when we put a new value in here. It has to be tied directly to this value. How can we do such a thing? Well, we usually use A1 format in Excel, which means you use an alphabet and then a number. So this cell is D3, this cell is F1. That's A1 format. You can also use row column format, where you would call this row 3 column 2, row 2 column 5, and kind of look up values just like that. So one thing that we can do is we can get the address of something. This is a command. It's called address, and what it does is it pulls the address of a particular cell based on the row and the column. So if we want to get the address of where these values stop, right now it would be G3. We could say that this is, we would look up the row number, which is 3, 1, 2, 3. And then we'd look up the column number, which is 1, 2, 3, 4, 5, 6, 7. Whoops, not 77. We want this in absolute, and we want it given to us in A1 style. So it's G3. Excellent. That's great. We can put formulas in here, though. So instead of just row 3, column 7, we can tie this to this value right here, 6. And all we have to do is say B4 plus 1. And it still gives us G3 right now. Because I could change this and say that there's 7 categories. Now it's H3. I could change it and say there's 2 categories. Now it's C3. So now it's tied to what we want. Let's take it back to 6. So right now, this doesn't 100% do anything for us. We've just got a cell address here. What we want to do is move that cell address here where we have it. So I want to put this code for address in here, right here. But even though this is displaying G3, this code isn't going to work right here. The reason for that is we need something called indirect. Right now, these are direct references, B3 and G3. They're direct. They're going to go... Ooh. Okay, that was weird. So these are direct references, and you type them in, and they're exactly what they say they are. What we want is an indirect reference. The indirect reference means that if I put in indirect E7, then instead of taking E7 as the cell that I'm looking at, it's referencing what's in E7. So this is still going to give me G3. Notice how it's still 5.44. So now I'm referencing with indirect the cell that I've got here. And the cell that I've got here is coming from this formula right here, referencing this cell. So we can put all this together. We can copy the formula that we've got here. And yeah, I know. We can copy the formula that we got there. We can come over here to this formula. And then indirect, we were referencing E7. Well, now I'm just going to plop in the formula that I stole from E7. And it's still 5.44. I can delete that. I can delete that. And there we go. Let's say we made a mistake. It's not 6. It's actually, there's only 4. Those other 2... Oh, yeah. So what about this? What if this was 100 and this was, that's 25 plus 63 is 58. Whoa. 108. So we accidentally grabbed this. Oh, that's just the total for these 4 right here. Whoops, okay, made a mistake. Then instead you can throw in 4, and now your degrees of freedom is 3, and your chi-square test statistic is 4.08. That's the sum of this cell, this cell, this cell, and this cell. To make sure that that's true, why don't we just type in equals sum, come over, 4.08. Ta-da! Okay. So now we can get rid of this. And we want to know the p-value. So the p-value is going to use a formula that Excel has. Chi-square dot test. And what it wants is the actual range and the expected range. So the way that they expect you to put this in is to put in the actual range, B2 through G2, and then in the expected range they want you to type in B1 through G1. Except our ranges change, like we talked about in computing the chi-square test statistic. So we can start by doing it the right way. B2 through G2, B1 through G1. And we'll get a p-value that shows that this is not significant. Okay, so what we want to do is we want to change these cell dependencies to match this cell dependency right here. I'm going to copy this, take everything but the last parenthesis, copy that, hit enter, otherwise you'll accidentally screw up your formula. And then where you've got G2, you're going to pop this in. Now it's not completely done yet. There's one last thing we have to do. What's going on here is, notice that it's taking, let's see, B2 through row 3, column B4. So we're doing row 3, which is this row right here. The row where we have our chi-squared statistics for each single category. What we actually want is row 2, where the observed frequency is. So all we have to do is change this 3 to a 2. And now we've got B2 through the second row, and then all this junk here, just going to tell us how far over this goes, because you're adding 1 to this number of categories here. We also need to change this to the same thing. But we have to change this too. Instead of row 3, now we're on row 1, right here in the expected range. So it should be, I can hit enter now and get almost the same formula. Oh, because I did, because when I did this the first time, I computed it for all 6. Now I'm just doing it for 4. If we change this back to 6, it's going to be 0.4, just like it was before. There we go, 0.4. Okay, and so there we go. This is your, you can now paste any values into here. In fact, let's try it. Let's just come up with some different values. Let's do 124. 100, 100, 100, 100. This is the expected column. We're going to do 124. We're going to do 70, which is a total of 194. We're going to do 54. And then, because I still can't do math in my head, 52. Wait, is that right? No. Because it should be 400. 152. Okay, so let's copy these numbers in. You can just type them in. You don't have to do that silly thing that I just did there. Go ahead and copy these numbers. We're going to right-click, paste values, and let's tell it that we only have 4 categories. And there we go. Everything is changed. The degrees of freedom is 3. The chi-square test statistic is 62.96. Does that make sense? We've got 21 plus 27, which is roughly, with with some change here, so this is like about 48. 57, yeah, 62. That makes sense. Great. And then the p-value, this is a pretty large chi-square test statistic. The p-value should be fairly small. And we've got e to the negative 13. So it's going to be a p-value of 0.12037. So this all looks pretty great. A couple things you can do just to keep it looking clean is you can get rid of that. You can take all of everything in row 3 and just turn it white. You don't need it there. Let's see, everything from here over. This is going to be green. This is something that you're going to change. So this is where the user changes things. We're going to make that green. The user changes this, so it's green. This is an output, so it is light orange, and so are these two. Okay, and there's your one-way chi squared. In the next video, which is going to be linked in this one, we're going to do a two-way chi squared, which is a little more difficult because it's, you know, you have rows and columns. And when you're trying to make a calculator in Excel with rows and columns, it gets a little crazy. But we'll figure it out. It's fine. Okay, that's it.